The world is thinking about other things like TikTok and bans and things like that, but we're going to talk about some AI. Great. Okay. All right. Welcome to Das Won't Hunt. I'm Zhao Pierre Ruth for Information Week. And in this episode, we're going to be taking a look at what happens if AI no longer has access to good data to train on. As various things happen on the legislation and personal interest space, there might be changes in data privacy regulations that might alter the way that data is accessible, what's accessible, and then there might be very alternatives that might need to be sought for, or different just ways that it needs to be sliced. Maybe it's a turn to synthetic data, or maybe using old data. But thing is, what happens if the data that we're using doesn't turn out to be the kind of things that AI really needs to be trained on? So to, again, dive in and take a closer look at this topic, we've got a great group of folks. We have Shobha Phansalkar, Vice President of Client Solutions and Innovation for Wolters Kluwer. Olga Megorskaya, Founder and CEO of Toloka. Pete DeJoy, Co-founder and Senior Vice President of Product for Astronomer. Melissa Bischoping, Senior Director of Security and Product Design Research for Tanium. And Omar Khawaja, Field CISO for Databricks. All of you, thank you so much for being on the show today.
Pleasure.
Good to be here.
Okay, great. All right, Pete, let's start off with you. What types of categories of data does AI need for training? Is it demographic data, sales pattern data? What typically are we looking at?
Yeah, it's a great question, JP. Generally, it really depends on what you're trying to do with the AI. Now, there's all sorts of different types of data that you can use to train and fine-tune models. Starting at like maybe the highest level of abstraction, you have things like text and image and video and structured data and documents, like legal documents are an example that get used a lot in the age of generative AI. But really, the context is very important, because you need the models that you're training to be able to produce predictive results for a specific task. At Astronomer, we work with a bunch of really incredible data teams on kind of training their in-house machine learning models and fine-tuning foundation generative AI models. One of my favorite use cases is the Texas Rangers, who use a ton of in-house machine learning to actually predict where they should be lining up their players on each pitch, and what a batter's swing mechanics should look like based on a pitcher's spin rotation or spin rate of the baseball and arm angle and all of these really incredible things. In that case, they're ingesting a ton of image and video data to actually do predictive analytics on how they can go win baseball games. On the other side of the house, we have Ford, who actually uses a bunch of infrastructure that we work with them on to train their self-driving AI models. And that's processing a lot of radar and LiDAR data, so proximity data from cars that are driving around in test-safe environments. So again, it really is dependent on the outcome that you're trying to drive and what you're actually trying to accomplish with the model. But generally, if there's data for it, you can train a model for it.
Gotcha. Thank you so much for that. Kind of following on to that, Shobha, where has data typically been sourced from to train AI? I mean, like where are we reaching into? Which buckets are we reaching into to kind of like gather this data and then feed it to the algorithms?
Yeah, great question again. I think I'd follow up by answering similarly to what Pete was saying. It depends on the problem that you're trying to solve. Coming from the healthcare perspective, the industry I represent is highly regulated and highly consequential. So when you're looking at patient safety data, you really have to understand the context of the problem that you're trying to solve. And if you're designing an algorithm, not only does it need aspects of who is this patient and what data set do they belong to, it's about whether patients have been represented adequately in that data set. So we've all heard about the ethics and the algorithmic biases that can be present in data depending on who's represented in that data. But the consequence of that in healthcare is highly is something to be very aware of, because this is what's being used for driving decisions. So when you think about kind of the consequence, then you think about, okay, what are the sources that I want to get this data from? There's so much fragmentation of data within healthcare, right? You're looking at ambulatory settings, you're looking at inpatient settings, you're looking at academic medical centers, which have a different way of decision making as compared to like community health organizations. And so representation of data and where it's being drawn from becomes extremely important. That said, in order to drive high fidelity within an AI algorithm, you also have to consider pharmacy data, HIE data, lab data, imaging data. All of this becomes highly relevant when you're trying to look at not just the entire context, but also the longitudinality of a patient. That needs to be considered when you're building a robust algorithm.
Great. Thank you very much for that. Melissa, how can organizations really determine determine the useful data for training versus essentially what might be junk? How do they kind of have a litmus test to kind of gauge that?
This is a topic that's near and dear to my heart. So before I got into tech, I actually I went through a psychology program in my undergrad and actually looked at going into research psych. And a lot of the same skills that we employ when we're considering how to design ethical, well-designed research studies on human psychology are the same ones we need to think about when we're designing AI algorithms and how we're going to build and train models. You'll hear really commonly people will say garbage in, garbage out, and that's a very simple way to put the problem. But I think it's a little more complex than that. You have to ask yourself, is this the right data for the job? And is the data actually right when I get it? That requires a little bit of speculation. You actually have to ask some critical thinking questions about, does this data make sense? Did I source it from a place that I know has accurate data, or is there, are we being honest with ourselves about whether or not this source of data could be prone to false positives? Are we over collecting on the types of metrics we're pulling back that could lead to a correlation causation issue? And I think that's probably what I caution people about more often is when you get results back from an AI algorithm, whether it be an LLM telling you, a fact, or when you're looking at a bubbled up metric, you want to ask yourself, does it make sense? And can I go validate the finding? Especially in my realm, we talk a lot about AI for security use cases. If you're a security analyst or an engineer who gets an AI generated finding, you want to know, can you go manually verify that finding to increase your confidence? Or is your, whatever tech stack you're using providing you additional data to enrich that, hey, I'm telling you the sky is blue. I calculated that the sky is blue based on these particular values in a camera sensor. That's how you build confidence in the model. And as we grow with this technology over the next several years and decades, confidence is going to become key to adoption.
Gotcha. Appreciate your input on that. Okay. Olga, can synthetic data fulfill the needs for training AI on a long-term basis? And is there real tangible difference in results when somebody's making use of synthetic data versus other forms of collected data that's out there?
Yeah, sure. This is a very interesting question in the modern industry. If we take a little bit zoom out and look at the data for AI, basically there are two major steps of training for every model. The first is pre-training, roughly speaking, when the model collects all the data it could reach, all the data from the internet, all the data from the textbooks, etc. And then there is the post-training, where the model behavior is being aligned with human expectations. This is actually the stage where we apply all the ethical and safety regulations, all the specific domain knowledge, and etc. And since we at Toloka are supporting the foundational model producers with human expert data for post-training, the question about usage of synthetic data and combining it with the human ground truth data is very up-to-date for us. I would say that synthetic data is a super powerful tool, and it is gaining popularity because really, and this is a miracle, that synthetic data can still produce useful signals and new information to train the models. At the same time, we need to keep in mind that it inherits all the limitations that the foundational model that synthesized this data actually had. If it had inherent biases, the data would inherit these biases. If it had some lack of knowledge within a specific domain, the data would inherit that. That's why we see in the long term, the future is in combination of synthetic data and some specifically crafted data, for example, by human experts, because ultimately you would always want to have ground truth human evaluation to control the quality of the models, and also some source of new knowledge from real world experts to gain the knowledge about the domains of expertise that were not covered yet by the foundational models.
Gotcha. Awesome. Appreciate your thoughts on that. Omar, this is a big question. Does AI die without data?
A lot of the way that we've been leveraging AI to date is we've been leveraging AI at least in this incarnation and exuberance of AI the last couple of years. It's been focused on accessing AI for knowledge. We ask it questions and we expect it to know answers to certain questions. So the larger the corpus of data that the model is trained on, the more answers that it will likely give, and the better it is post-trained and fine-tuned, the more we can trust those answers. And as the world has less data for a model to train on, then of course the model will end up knowing fewer things. The big opportunity that we see across many of the enterprises we support isn't necessarily leveraging AI for general knowledge. And that's something that for general intelligence, which is something that as an individual, I love using AI for general intelligence and for searching and having conversations. However, from a work and enterprise perspective and how we serve our customers, there's very limited utility of that. Where there's more value that is emerging from AI isn't in the knowledge that the model has, but the skills that the model has. So this idea of agentic AI or compound AI, and a key component of that isn't the data itself, but rather its ability to reason. And when it knows how to reason, now AI has some skills, and those skills aren't based simply on the knowledge it was trained on, but these skills are based on what it can do. So now I can use AI to connect to my databases, connect to my teams, connect to my people, connect to my applications. There, I'm going to be able to unlock significantly more value from AI. And of course, there's things like RAG and others that are on that continuum, but ultimately to leverage AI for the things it's good at, to do the reasoning, but to actually unlock enterprise data so we can get to the point where we don't just have general intelligence, but we have data intelligence that allows you to leverage the data that you have. This is where a lot of organizations are sort of hitting up against a wall and feeling like AI isn't very effective because they haven't quite figured out how to integrate AI into their larger data estate. Once they figure that out, they're going to really unlock more value. And it isn't going to be about the foundational models' access to data. It's going to be leveraging the data they already have in-house. And the connective tissue there is going to be the agentic AI and chain of thought.
Good thoughts. I appreciate your insight on that. And again, I appreciate each of you on your individual thoughts. I'm going to take some of the other questions that I had. I'm going to compress them together and see if we can get all your collective thoughts on this. What policies or are there policies, be it the state, national, international levels that might make the process of gathering data to training AI a little more complicated, complex? And again, kind of going back to the does AI die without data? What happens if there is more of a movement that could drastically change where these policies are even further in terms of that accessibility? Just all of you, I appreciate your thoughts.
I can start with that. I think, healthcare as an industry probably is most restrictive in terms of how data is shared, and rightfully so. There are a lot of ethical considerations in terms of patient identity. So we certainly have HIPAA, which I think most of us are aware of in terms of data sharing regulations. But there's also state mandates and state regulations that are specific to how data is shared across providers, across healthcare entities, and who you're sharing that data with. And consequently, who can sign off. Of course, the patient being that core entity that should be given the power to sign off who their data is being shared with. We at Health Language not only keep an eye out on the federal regulations, but we also have offerings that allow our customers to basically mask data, sensitive information that should not be shared across organizations. So we keep an eye on the federal regulations, the state-specific regulations, because each of these mandate what data is being shared between the provider and an HIE or a provider and a payer. And certainly at a federal level as well, there are regulations that the ONC has in terms of how and what standards drive the sharing of data between these entities.
Great. Any other thoughts for the rest of you on this?
I'm happy to add some more thoughts. I think, on the one hand, there's laws that are increasingly establishing moats and restricting sort of the ubiquity and democratization of AI models, applications, and the data, and enforcing and coming up with even stricter data sovereignty laws. There's some that came out from the White House even as recently as a few days ago. Those are going to be there. What I typically see in organizations, and even HIPAA is a good example, where people don't necessarily understand what the expectation is of the law. So for instance, the average person will say, because of HIPAA, I am not allowed to send my PHI overseas. HIPAA actually has no such restriction. The challenge I see with some of these restrictions and some of these laws is that we over-index on what we think is the restriction. And as a result of that, we slow down the ability to leverage some of these advanced technologies to unlock our data and to better serve our customers. To me, that's the bigger concern. It's not the law itself, but it's our poor understanding and perception of what the law is actually asking for.
I think, Omar, you make an excellent point. I think to tie that back to the topic of this discussion, what you said hits home, because oftentimes when that data is aggregated across, a population, you don't know what the context of or source of that data was. So you don't know if certain conditions or diagnoses have been masked. And you might train your data set without that context and consequently result in very biased decisions. And because these regulations vary from state to state, and you may not carry that information forward of the address of the patient or where they were, where that data set was coming from, there are obvious biases that might be implanted.
And Shobha, you're right on, because for most people, they'll say, if I'm not sure, then I'm going to err on the side of caution. And so what we want organizations to be able to do is to operate with confidence, to have fewer situations where they say, we don't know, we're unsure, for there to be clear lineage, for there to be clear ownership, for there to be clear tracking, for there to be clear governance. So then you're making decisions based on not a position of lack of knowledge, but from a position of confidence. And when we have confidence, we're likely to do things without feeling like they're in fact risky.
Yeah, absolutely.
Right. I'll give you all one last question. Hope you have some input on this. How often must data really be refreshed in order for it to remain relevant for the purposes of training AI? The idea of like dinosaur data, just kind of like, oh, we're going to keep training with this, but then what kind of results are you actually going to get in working with this AI? How often should organizations be looking at, keeping the data that they're trying to use for the training purposes really, live and fresh?
I'll start with this one. I think kind of goes back to the question I answered previously about knowing the purpose of what it is you're trying to answer. If you're doing research on historical trends or on looking for patterns in like human genetics or like medical diagnoses, that may be something you can use older data and keep that data around for a while and really deep dive and analyze. If you're looking at things like cybersecurity and emerging threats and 0 days and new threat actor TTPs, we obviously have to have a much faster cycle on how we're ingesting new data and learning off of it. Same thing even in the IT operations space for data. You want to be, every day a different vendor releases an update to a software, and now that software looks differently. So if you're using any of that information that changes that frequently and you're trying to make decisions in real time, the data has to be refreshed more quickly. If you're looking for more historical trends and you're doing those kinds of research projects, I think you're safer to use data that is a little bit older.
Again, I would say it depends on the diagnoses that you're going after. You mentioned the the medical data. Inpatient data is drawn at a much higher level of granularity and fidelity as compared to outpatient data. I mean, most of us go to an outpatient PCP when we have a problem, but when you're in an inpatient setting, your vitals, your stats are being drawn at a much higher frequency as compared to going and getting a blood pressure reading with your primary care provider, at your annual wellness visit. So I think that's where the fidelity of the data comes in. What problem are you trying to solve? What is the context of that problem?
I actually like that example a lot of looking at like emergency or inpatient medicine.
Yep.
Is looking at like long-term treatment, like planning medicine. I think both of those are really good use cases to illustrate when one is a better fit than the other.
Yeah, exactly.
Yeah, I think aligning to the underlying rate of change of the system or the rate of improvement you're looking for to get out of the AI. But either way, it's going to be alignment to the change. One metaphor I think of is how often do people need to be trained in their job? If my job is the same as it was the last 10 years, I may not need additional training. If I happen to be a retail salesperson, my job may look exactly the same. But if I'm a software engineer, the rate at which things are changing, in order for me to successfully operate in my role, I'm probably going to need more and more training data to just keep up to speed with expectations.
And one last thing I think that's you sort of alluded to there, but I want to double tap on is when there are new advances in whatever the field or the discipline is that the data is based on, like if all of a sudden you are, maybe you're doing some sort of pharmacology research and there's a new chemical compound that's unlocked, you want to be able to include that information in your model, even if nothing else in the industry has changed. We know that's kind of a dramatic example, but if there's a significant advancement or change in the field or in the topic area itself, that might warrant going back and looking at the model.
Gotcha. Great. All right, listen, any other final thoughts on that question? Listen, I appreciate everyone's time and being on the show today. Omar, Olga, Melissa, Shobha, Pete, I thank you for being on the show today. Thank you so much.
Absolutely. Pleasure.
To listen to the entire conversation, look for the Das1 Hunt podcast on Spreaker, Spotify, Amazon Music, and other popular podcast platforms.